Alright, Chapter 3, Demodulation. Just testing to see if the timer's running. I screwed up on the other tape. The debit gave up on me. Alright, Chapter 3, Demodulation. Upon completion of the chapter, we'll be able to describe the continuous way the detector circuit operates for the heterodyne of the regenerated detector, describe the requirements if they recover the intelligence for the AM signal, but describe the theory of the operation following the analog modulator, amplitude modulator, demodulator, series diode, shunt the diode, common emitter, the common base. Describe the frequency demodulation circuit operates with phase shift with the graded beam discriminator ratio detector demodulator phase. Describe the phase demodulator circuit that operates with a peak low pass filter circuit version of detectors. Introduction. In Chapter 1, with the youth to apply with the intelligence modulation of the radio frequency carrier wave, the carrier modulation allow with the transmission modulating frequency without the use of the transmission wire, the medium have with the communication profit, the capability of the use intermediate intelligence must be covered with the original receiving the drive the process of recreating the original modulating frequency intelligence of the radio frequency carrier with the referred to the demodulation detection. Each of the modulation differently will require the different sequences to recover the demodulation of the intelligence. In this chapter, we will discuss the wave of the demodulation, amplitude modulation, the continuous wave frequency modulation phase, and the default pulse modulation. In the circular restoration, achieve the detector and demodulation, both with the term of the need for the term demodulator, the between the demodulator profit, the conserve the opposite, the demodulation output of the ideal detector must be exact for the reproduction demodulation exists, and with the radio frequency wave failure to accurately recover the intelligence will result with the distortion degradation of the demodulating signal, where the intelligence will be lost distortion made amplitude frequency favor depending on the nature of the demodulator. The denominator device was required for the demodulation. The denominator device required to recover the demodulation frequency with the radio frequency envelope. Solid state detector circle may be either the positive negative junction diode or the input junction of the transistor electron tube. The circle is either diode or greater plate circuit of the triode electron tube with maybe even the denominator device. Alright, continuous wave demodulation. Continuous wave demodulation consider the on-off key with the carrier wave to recover the on-off key of the information that you the method detection present the absence of the oscillation. Continuous wave demodulator took with the presence of the radio frequency oscillation and converts them from the recognizable form. Figure 3.1 illustrates the receiver, the continuous wave of the UA with the rectifier with the continuous wave of the diode detector of UB and the DC output of the filter with the with the control, the relay with the light indicator of UC. Receive the continuous wave demodulation. Receive the continuous wave to reach rectify the continuous wave from the detector average way DC, DC through phones, time output filter. Figure 3.2 simplify the circle with the with the continuous wave demodulator. Antenna receive the radio frequency with the oscillation from the transmitter of the tank server with the inductor 1 and capacitor 1 acts of the frequency selected network through the tuned desired radio frequency current or frequency diode rectify the oscillation current capacity to provide the filter provide the constant output with the control with the head side of the demodulator circuit with the equivalent of the wire telegraph circuit that has certain advantages. For example, the two transistors are very close to the frequency distinguishing the transmission station. You can receive the often impossible without a method of tuning, fine-tuning the desired frequency. As the stations without the frequency band path of the input tank circuit, the tank output will contain the mixture of the both signals. Therefore, a method such as the heterodyne detection must be used to provide more than just the information on the presence or absence of the signal. The antenna, transformer, inductor, capacitor, adjustable capacitor, diode, capacitor 2 headset, the continuous wave demodulator. Your heterodyne detection, you for the audio frequency of the voltage for the detector, A for the operator, the sequence between the various signal, the signal, the carrier, the unmodulated audio frequency can be developed with the heterodyne procedure that discussed in Chapter 1, procedure that makes the incoming continuous wave will locally generated oscillation procedure, conventional difference frequency of the audio frequency range from the 1000 Hz, the audio frequency difference of frequency rectified smooth by the detector, audio frequency voltage repeated with the telephone headset with the loudspeaker that called show the heterodyne reception of the code letter A that shown the U of the A3 of UA with the code consider the short burst and calling the continuous wave the energy dot followed by the longer burst dash. Assume the frequency of the receiver the continuous wave signal at 500 kHz. Locally generated oscillation adjusted the frequency with the higher lower the incoming radio frequency signal to 501 kHz. In this case, shown the UB voltage relevant the heterodyne action between the continuous wave signal of UA and the local of the oscillator of UB, then shown the UC with the mixed frequency signal envelope. The intelligence amplitude varies in beat difference from 1000 Hz to 500, 1000, 500, 1000 negative half cycle with the mixed frequency rectified and shown the UT. The peaks of the positive half cycle follow the 1000 Hz beat frequency. The received continuous wave signal heterodyne detection, received continuous wave signal local oscillator signal heterodyne detection, local oscillator signal mixed frequency signal heterodyne mixed frequency signal, and of the rectified mixed frequency signal heterodyne rectified mixed frequency signal. The DC audio note from the filter audio. The continuous wave signal pulsation or remove the radio frequency filter detector output with only the envelope of the rectified pulse will remain. The envelope shown in the view E, the 1000 Hz audio beat note that the 1000 Hz dot dash may be heard with the speaker headphone. The identified letter A, the operator of the heterodyne method reception highly selective that allow little frequency interference with the adjusting the continuous wave. The continuous wave signals the radio telegraph stations operating at 10 million Hz. At the same time, adjacent to the station with the operating at 10,300,000 Hz, the simple detector cannot clearly discriminate between the two stations between the signals just 300 Hz apart. With the band passive of the tuning circuit that's too wide allows some of the other signals to interfere. The two carrier frequencies differ only with 3,000%. The tune tank circuit cannot easily discriminate between these. However, the heterodyne detector local oscillator frequency of 1,000 to 1,000 Hz is used. The beats notes of 1,700 Hz are produced by two signals, the other frequency which can be distinguished easily. Selective circuit because of the difference of 30% compared to 3,000% above. Even if the station produces the identical local frequency, they can be separated adjusting the locals oscillator with the B frequency, the oscillator with the BFO frequency. For example, the second station previously explained with the heading operating at 10 million to 2,000 Hz, the both stations would have produced 1,000 Hz beat frequency, and interference would have occurred. Adjusting the load oscillator frequency to 9,999,000 Hz have caused the desired station 1 million Hz to be produced 1,000 Hz beat frequency. The other station 1,200 Hz would have produced a B signal frequency of 3,000 Hz. Either selective circuit of the operator can easily distinguish between these very wide differing tones. The train operator can use the variable local oscillator to distinguish between the stations and the varying frequency another few hundred hertz. Alright, the regenerated detector. The simple one transistor regenerated detector circuit with the U with the heterodyne principle of the continuous wave that's shown with the gate 3-4 with the circuit that may be oscillated with the increase the amount with the energy fed back with the tank with the out of the collector output with the physically moving the tickler coil with the inductor 1, closing the inductor 2 with the U of the regenerated control of the feedback, overcome with the loss of the base input circuit with the self, the oscillation with control with the tuning capacitor 1, receive the signal from the antenna, the oscillating frequency both present the base of the transistor 1 with the total few frequency or heterodyne nonlinear transistor, the resulting beat frequency that rectified by the emitter base junction produce the beat note, which is amplified in the collector output circuit with the audio frequency current with the collector current and circuit actuates the phone with the regenerated detector figure 3-4 produce their own oscillation heterodyne themselves. The incoming signal rectified and detects them. The tickler coil inductor 1 inductor 2 regenerated coil resistor 1 2 capacitor 2 adjustable capacitor also shows the tuning circuit and capacitor 3 for the headphones voltage current collector. The regenerated detector is used to receive the shortwave code signal because of the easily adjusted the higher sensitivity because selected for the higher frequency amount of the single detecting the tuning to that server they produce the audio beat turning the small percent of the single frequency code with no trouble. The use of the regenerated detector low frequency code reception, however, usually avoided. Low frequency detuning required to produce the proper audio beat frequency percent of the single frequency, although the type of the detector may be used in amplitude modulation signals as high distortion is not often used. Alright, amplitude modulation, demodulation. Amplitude modulation refers to the method of modulating electromagnetic carrier frequency with the varying amplitude of the accordance with the message intelligent to be transmitted. This accomplished heterodyne intelligent frequency with the carrier frequency with the vector, assumption of the carrier, sum of the difference frequency with the causing the modulation, vary in the amplitude of the intelligent frequency discovered in Chapter 1. In Section we'll discover the circuit with the recover the intelligence variation modulation envelope. Alright, your diode detector detection of the amplitude modulation signals evidently with the accomplished mean with the diode rectifier, which may be either a vacuum tube semiconductor diode with the base detector circuit is shown with the simplest form of the view A figure 3.5 with the view B, C, and D shown. The circuit waveform of the demodulator must meet three requirements. One, must be sensitive to the type of the modulation amplified with the input. That must be nonlinear, must provide the filtering. Remember that the amplitude modulation waveform appears like a diagram in view B. Amplitude variations peak present the original audio signal. No modulation signal frequency exists in the waveform. The waveform consists only of three radio frequency frequencies. The carrier frequency, sum of frequency, difference frequency, the modulation intelligence is contained with the difference between the frequencies. The vector attained with these frequencies is provided with the modulation envelope, the approximately the original modulating waveframe of the modulation envelope of the diode detector produce the original modulating frequency. Alright, antenna transformer, 1, inductor code, 1, capacitor, adjustable capacitor, diode, capacitor, 2, headset, series diode, detector wave shape, then circuit. Radio frequency input time and the voltage signal the series detector wave shape, then radio frequency input with the voltage time the rectified signal series diode detector wave shape rectifier signal voltage, audio signal time, series diode detector. Let's analyze the operation circuit shown with the U8 with the figure 3.5 of the circuit bay for the type of the diode, receiver of the dome, the series of the diode, detector circuit, consider the antenna-tuned inductive capacity of the tank circuit with the semi-demo detector, headset with the maybe bypass of the capacitor to the antenna, receive the transmitted radio frequency energy feeds into the tuned tank circuit. The tank circuit with the inductor 1 capacitor tuned select with the radio frequency will be detected with the tank is resonant is selected with the frequency which shape of the VUB. Develop the curve of the tank circuit because the semiconductor the nonlinear device can with only one direction eliminate the negative portion of the radio frequency carrier with the produce the signal shown in the UC. The current of the circuit must be smooth before the headphones can be reproduce the audio frequency intelligently. The action you tube the capacitor 2 acts as the filter provides the output with the proportional peak of the radio frequency. The filter offers low impedance for the radio frequency with relatively high impedance for the audio frequency. Filters were discussed in each module 9. Introduction wave generation wave shape circuit. These action capacitor 2 develop the waveform VUD, the varying voltage applied with a headset, which reproduce the original modulation frequency of the circuit and coupled with the series diode detector, sometimes referred to as the voltage diode detector, because of the semi-diode is series with both the input voltage load with the impedance voltage circuit causes the output voltage to develop across the load impedance that in proportional input voltage peak the modulation envelope. Or your shunt diode detector, figure 3.6 with a similar to the series diode detector, except for the output variation current of the volts rather than voltage pulse. Passing the current through the shunt of the resistor develop the voltage output the input of the radio frequency modulated envelope on the negative half cycle of the radio frequency diode over the diode 1 forward by with the shunt the signal over the ground on positive half cycle of the current flow for the output of the through inductor 1 to the input. The field built around inductor current 1 tends to keep the current flowing in action with the radio frequency current through pulse for the cover the output of the file with the modulation envelope intelligent closely. Integration will discuss in each module 9 introduction wave generation wave shape and the circuit of the shunt the resistor 1 develops the output voltage thus the current flow author the shunt detector operated with the principal current flow and output voltage across the shunt resistor that used to reproduce the original modulation signal. The shunt diode detector is easily identified noting the detector diode parallel to both input and load impedance. Waveforms associated with detectors and identical to show the B, C, and D of the figure 3.6. Radio frequency diode and inductor resistor 1 audio frequency output. Shunt diode detector. Alright, your series diode detectors normally use the large input signal supplied linear output require the shunt detector diode to achieve the voltage variation too small to produce the full output of the audio amplifier stage. The additional current amplifiers required to bring output to a usable level on method of the detection amplification has developed with a detect low level signal. Next section will discuss these two circuits common emitter and a common base detector. Common emitter detector is used with the receiver that supply with the amplified detective output of the schematic typical transistor common emitter detector shown figure 3.7 of the transistor 1 with tuned primary act with the frequency selective device and the inductor 2 inductively couples input modulation envelope with the base of the transistor with the resistor 1 and resistor 2 fixed bias voltage divider the bias level of the transistor 1. Resistor 1 is bypassed by capacitor 2 limiting the radio frequency. Resistor capacitor combination also acts as the load in the diode detector emitter base junction of the transistor. Detected audio is with the basic voltage can control the current collector. The output is developed. The resistor 4 will also bypass remove the resistor for radio frequency from the capacitor 4 with the resistor 3. The temperature stabilization resistor capacitor 3 bypass the both radio frequency and audio frequency. Okay, you have radio frequency, the capacitor adjustable inductor transformer, inductor 2 winding, capacitor 1 extracting low resonance, high resonance, capacitor 3, resistor 3, and capacitor 4 on the your other carrier message in 4 and 5. I don't know. Transistor 1 base, the slight conduction of the input signal, but the input signal appear with the base of the transistor rectified emitter base the operating of the dial developed the resistor 1 of the AC DC voltage DC bias voltage verifying the component of the voltage controlled the bias of the collecting current of the transistor 1 output developed the collector current flow through resistor 4 and a radio frequency amplified output bypass the volume the collector load resistor of the capacitor 4. The audio frequency variations are not bypassed after the modulation envelope is detected by the base circuit. The amplified circuit to provide the simplified audio frequency output of the audio output is higher than the possible simple detector because of the amplification within circuit weaker signal detector with the simple detector higher the more usable output is this developed. Alright, common base detector and any other amplifying detector that is used with a portable receiver. The common base detector and circuit the direction of the curve of the emitter base junction, the amplification curve of the output of the collector junction, the output developed equivalent diode detector followed by the shape of the audio amplification with the more distortion. Figure 3.8 simple schematic of a typical common base detector. Transformer 1 is tuned with the bi capacitor 3 with the chain frequency with the incoming the modulated envelope of the resistor 1 capacitor 1 self-biasing network sub the operation point of the emitter junction, the audio frequency output of the take of the collector circuit of the audio transformer 2 primary with the transformer 2 detector output is bypass of the radio frequency capacitor 3. Common base detector, radio frequency transformer 1, inductor 2, capacitor with 3, adjustable capacitor 1, resistor capacitor 2 on the transformer 2 audio frequency. Input signal with the output of the transformer 1 when capacitor 3 is tuned with the proper frequency signal base with the emitter with the transformer 1. No input signal with the present of the output determined by the resistor 1. When the input signal becomes the power of the current flow through the emitter base junction causes it to be forward by with the capacitor 1. Resistor 1 is set with the DC operation point by acting the filter network. The action provides varying DC volts with the pulse of the heat with the radio frequency modulated envelope. The action identical to the desired detector emitter base junction. During the detection, varied DC voltages on the emitter chain with the base of the bias of the transistor 1 cause the collector current to vary in accordance with the detected voltage of the transformer 2 to couple of the current chain with the output of the transistor 1 detect the amplitude modulation wave that provides the amplification to detect the waveform. The 4 amplitude modulation detectors just discussed are not only this type of the will encounter, however, they are representative that only of the most amplitude modulation detector sample characteristics will be found in amplitude modulation detectors. Now let's study some of the demodulation frequency modulation signals. Alright, frequency demodulation signals. We're going to make sure the tape stops.